So I've gotten a few questions about compounding interest versus simple interest. And compounding interest, the reason it's called compounding is because you get interest on the interest. So let's go ahead and take a look at this example where we're starting out with $500. And then we're either getting simple interest or linear interest on that $500, or we are getting compounding interest. So let's go ahead and take a look at the first 3 years. And so we've got one, two, three. This is our time. And so this is simple, and this is compounding. Okay. We're always going to have the $500 that we started with. And then we're also going to have the interest that we've earned on it. So in all cases, there's going to be the original $500 that was deposited, and then there's the money that is added. So in this case, we have got 7% interest, and the first year there's nothing to compound it on, so they're both going to make exactly the same interest, and that is 500 times 0.07. Why times 0.07? Because we've got to translate percentages into decimals, meaning we've got to move the decimal over 2 places. And we see that 7% interest on $500 is $35. And with the simple linear interest, we're just going to make that $35 every year. And this first year in the compounding, there's nothing really to compound yet. We're just making our first year of interest. But now let's look what happens the second year. We're not going to make 7% of the original 500. We're going to make 7% of the 535. In other words, we get paid interest on our interest. So now we have to say 535 times 0.07. And we can see that's $37.45. I mean, not that exciting. We've made less than $2.50 more, but $37.45. Well, and I guess I should make it clear here that this is plus 35 plus 35, and then plus 35 plus 35 plus 35. In other words, we're adding 35 every year. Here we've got our original 500 plus our 35 from the first year, but now instead of 35, we're adding 37.45. And so now our total balance in the account, 500 plus 35 plus 37.45 is 572.45. And it's going to be plus this 37.45 plus whatever the interest on 572.45 is. And we multiply that out, and that's $40.07. So this is plus $40.07. And so you can see here, every year we're adding the same amount to the account, another $35, the 7% of the original deposit. But with the compounding interest, first we added 35, but then $37.45, and then $40. And of course the number is just going to keep getting bigger every year because the balance in the account is getting bigger every year. Okay, if we're increasing by the same rate every year, that means that the rate is linear and that this one has to be the simple interest because we have the same change every year. We're just adding $35 every year. But here, this one is going to have to be the compounding. And you can see that the compounding is getting more powerful over time. In the beginning, the extra interest is only a few dollars and a few cents. But over time, it starts to compound, and so we end up having this very obviously exponential shape. In the beginning, they look very similar, but by the end, it is compounding. So what we're asked to do in problem 65, we just need to identify which is which and explain the reasoning. And in part B, we need to verify our answer in part A by finding the equations that model the investment growth and graphing the models. Okay, so we know that for a linear equation, it's y equals mx plus b, where this is the intercept and this is the slope. So go ahead and make your best attempt to plug in, and this is the y-intercept. In other words, what's the starting amount and what's the change every year? For the compounding, you are given an equation on page 294, blue box, annually compounding interest. So you're giving continuously compounding and periodically compounding interest. Do your best to plug the figures in to the formula for the periodically compounding interest. And that will allow you to complete problem number 65. Give it your best shot.